Hey guys, this is a video for 7.7 arc length and sector area. So as a warm-up question, we want to find the area and the circumference of a pizza whose diameter is 16 inches. So the first thing that we need to know is the area of a circle is going to be pi r squared, and the circumference is 2 pi r. So looking at the diameter, ask yourself, what do you need from the diameter so that you can plug in the missing information into those two formulas. So the first thing is diameter, we know, is 2 times the radius. So if the diameter is 16, then that means that the radius is going to be 8. Okay, so with the radius being 8, you can just substitute those values in. So pi times 8 squared, that's going to be 64 pi. And then for the circumference, we have 2 pi times 8, which is 16 pi. Okay, so just kind of a quick refresher on circumference and area. All right, and if your pizza were cut into 8 slices, what would the area of just one of the slices be? So if you have a pizza and you cut it into 8 equal pieces, okay, if you know the entire area of your pizza is 64 pi, and there's 8 equal pieces, then you can divide those pieces, the total area, by 8, and that's going to give you the area of just one of your pieces. So that's 8 pi. Similarly, for the crust length, if we know the entire length of our circumference is 16 pi, and we divide by our 8 pieces, that's going to give us each of the crust length is going to be 2 pi. All right, so just a quick refresher on area and circumference. All right, so arc length is the portion of the circumference. We set up proportions between the arc length and the circumference and the central angle. So if you have the circumference is 2 pi r, the total circumference is 2 pi r, arc length is some proportion of that total circumference. And similarly, if your total degrees is 360, theta is some proportion of the 360. So your formula that you're using for arc length is going to be 2 pi r theta over 360. Okay, so theta is going to represent the central angle created by the pizza slice. Okay, so the difference between an arc measure and an arc length: an arc measure tells us how many degrees of the total 360 there are, whereas an arc length is like if I were to stretch out this whole piece on a ruler, I could measure that total length. All right, so just an example here for you. Arc length equals 2 pi r theta over 360. Okay, so if my radius is 3 and my theta is going to be 124, I'm going to get arc length is 2 times pi times 3 times 124. So I'm just substituting those values in over 360. And I'm going to plug that entire thing into my calculator just as it's written. So 2 pi times 3 times 124 over 360. And that'll give me something called an exact answer. The exact answer has pi in it, but I can also get an approximate answer by pressing that double arrow button on the calculator, and that's going to give me 6.49. All right, so moving on to next example here. So if we want the arc length of BC, I can find the central angle using the idea that CA is a diameter. So if CA is a diameter, then that means that my theta is going to be 180 minus 150, which is 30 degrees. And similarly, it shows me that CA, which is the diameter, is 34. So half of the diameter is going to be the radius. So the radius is 17. And then just substituting into our formula, nothing too complicated here. So 2 pi r 17, theta is 30, over 360. Your exact answer is 17 pi over 6, or approximately 8.90. All right, so say if I give you the area of the circle and ask you for the arc length when the intercepted arc, so that central angle, is 37 degrees. So in this case, what information is missing for me to substitute in my values? What don't I know? And I don't necessarily know the radius in this case. But if I know the area of the circle is 25 pi, and area is pi r squared, then I can set 25 pi equal to pi r squared, and I'll get that I can cancel out the pi's, so 25 equals r squared. Find the square root. R is 5. And then I can just go ahead and plug my values in just as I would before. So 2 times pi times 5 times that intercepted arc of the central angle, 37, over 360. So my arc length is 37 pi over 36. So you should be able to go pretty comfortably between the approximate and the exact answer. All right, now that was arc length, but what happens if I want you to find something called a sector area? It's like looking at a piece of pizza and asking you how much pizza did you eat out of that one slice. So a sector area is a portion of the space inside of a circle. To name a sector, we use one arc's endpoint and at the center, and then the other endpoint. So I could say that if this is my sector, let's say A, B, C, I'm going to say sector A, B, C. So instead of like an angle this time, it's actually telling you the entire piece of the pizza. All right, so similarly to arc length, if we take the proportion of the area, so the sector area is a portion of the total area, which is pi r squared, and that's going to be equal to theta, which is a portion of the total degrees of a circle, over 360. So my formula for sector area is pi r squared theta over 360. So it's very similar to what you're seeing for arc length, but this time we're finding the area of just a piece of pizza. All right, and for example, so I'm looking at the bottom left picture. So if my formula is sector area pi r squared theta over 360, okay, just substituting the values in that I know that AB is 4, so that's my radius. My intercepted arc of the central angle is 73. So pi times 4 squared, 73 over 360. Plug in that value into my calculator. Exactly how I see it. Don't forget to square the 4. I think that's where I see probably the most mistakes. And that gives me an approximate or an exact answer of 146 pi over 45 and an approximate answer of 10.19. Okay, and then if I wanted to find the perimeter of the sector, I'm going to need to find the length of all 4 pieces, or all 3 pieces of the sector. So the arc, and then also the 2 radii, which I already know. So I know that the radius is 4, so that means that AC is 4, AB is 4, and then to find the arc length of this guy, you have to use that arc length formula. So arc length equals 2 pi r theta over 360. So 2 times pi times 4, 73 over 360. That gives me, and I'm going to just use the exact answer here because I want my perimeter to be exact. It's like if you're trying to do fencing, you don't want to approximate and then have a hole in your fence, and then you don't want your animals to get out because that'd be sad. So that's going to be 73 pi over 45. And then to find the total perimeter, I'm going to add up all of those lengths. So I know that AC is 4, AB is 4, and then my arc length is 73 pi over 45. So my total answer is approximately 13.0 And I'm going to go ahead and round that up, 13.10. All right, if the measure of the arc length is 3 pi, what is the radius? So if my arc length is 3 pi, and I've got pi, 2 pi r theta, and I'm given theta here at the bottom right, it's going to be 40. So I can't leave out the radius and the central angle. I'd have to give you at least one of them to solve and work backwards. All right, so from here, this is kind of like working backwards, a little bit tricky. I'm going to multiply by 360 on both sides. That's going to cancel out the denominator on the right side. So 360 times 3 is 1,080 pi equals 2 pi r times 40. And then I can just honestly divide. All of these numbers are being multiplied together, so I can divide by all of the numbers as well. So 2 pi and 40. And that's going to cancel out those. So 2 pi 40. Notice that I have a pi on the top of the denominator and a pi on the bottom. So the pi's just cancel out. And I'm basically just doing 1,080 divided by 80. That's going to give me my radius, which is 13.5. So my radius is 13.5, and then I can find the area of the sector by using that formula, pi r squared theta over 360. So pi r we just found is 13.5 squared. The intercepted arc we know is 40 divided by 360. And that's just going to give you pi times 13.5 squared 40 over 360, which is 63.62. All right, so that's kind of just arc length, sector area, not too difficult. Make sure that you are practicing and asking